right? So today we'll be learning about content-based filtering. So content-based filtering uses information about the description and attributes of the items users have previously consumed, which can be used to model their own preferences, right? So in other words, the content-based filtering algorithms, they try to recommend items that are similar to those that a user has liked in the past, right? So so let's see what are the some of the major highlights or points for content-based filtering algorithms or approaches. So they leverage description or attributes from items the user has interacted to recommend similar items. So it depends only on the user previous choices, making this method robust to avoid the cold start problem. So remember, we had encountered this cold start problem in collaborative filtering, where we, let's say, did not have enough uh, items which were interacted by a user in history. So that led to a problem. This will not be a problem in content-based filtering, right? So so if you talk about for textual items such as articles, the data which we are looking at earlier, it's simple to use the raw text to build item profiles and user profiles, right? So you already know about the TF-IDF vectorizer, and this is what we'll be using to find the similarity between articles. So we'll be coming up with recommendations, which articles are the most similar to a given article, right? So let's see how this works. Okay, so we are using the same data set from earlier. This is the CINT Dexdrop data set in which we had the information about the uh, users and their interactions, right? So users basically, uh, so this was the data, right? So here, so this was the article CSV. Here we had the content ID, and then the URL, and then the title, the text, and the language. Okay, and then we had another data set in which we had the user's interaction. So how a user is interacting with the content, right? And we had different event types such as view, follow, like, etc. Right? So all those things will more or less the same, right? So here we'll use the same function and the same weights to define the event strength or the interaction strength. So right, so this is how we calculate the event strength, which we have already seen in the class of collaborative filtering, right? And then you remember that we had around 1895 users, and we're only focusing on those users which had at least 5 interactions. So this thing will sort of try to keep consistent for just the sake of consistency, right? And then so we had also found out that the total number of interactions was 72,312, and if you only focus on users with at least 5 interactions, those were around 69,000, almost 70,000, right? And you remember we had a function smooth user preference, which helped us to smoothen the event strength, right? So we're doing a log transformation on that, and that was giving us smooth distribution for the event strength, right? So these things are more or less the same from the last class. And what we had done, that we had done a train test split, and we were doing a stratified sampling, and the test size was 20%. Okay, right? So these things are more or less the same things which we have seen earlier. Now let's talk about how we can use the TF-IDF vectorizer and come up with a sparse matrix, which can be then again modeled to recommend items for a given user, right? So you remember the TF-IDF vectorizer. So I have talked about this quite enough, right? So TF represents how many times a particular word appears in a single document. If you are looking at a normalized term frequency, so you'll have another term in a document, which is the number of tokens or words in that single document, right? And then we had another term which is IDF, which is an acronym for inverse document frequency. So this is calculated by taking the log of the total number of documents in your corpus divided by the number of documents in which that particular term exists. Okay. So IDF handles the rare words in our corpus. Okay. So moving forward, remember in our articles data set, we had two types of languages. One was English and another was Portuguese, right? So you remember in this data set. So if you explore this data set a bit, so in this we'll not only have English, but we also have Portuguese. Okay. So what we'll do, we'll create a stopwords list where we'll combine both English and Portuguese. Okay. So we'll sort of mix both of them together, right? So here I'm importing the all the stopwords which come from the English language and all the stopwords which come from the Portuguese language, right? And then add them together, so that will be our total set of stopwords list, right? Now we create a vectorizer object, right, using the TF-ID of vectorizer, in which we are considering not only unigrams but bigrams too. Our min df is quite small. That means around um, this is 3 by 1000, right? So you can consider that. So we have we'll only be considering those words which are present in at least 0.3% of the documents, right? And then max df is zero point 0.5. That means we'll only be considering those words which are present in less than 50% of the documents, right? So those words which are present in more than 60%, 50% of documents, will not be considering those, right? And the max features we have restricted to 5,000, right? So the maximum number of columns or word features we can come up with, that will be restricted to 5,000. And then in stopwords, we can provide the list which we have already created from here. And so this is our vectorizer object. Okay. Now we of course we can create the item IDs using the content ID, right? So content ID is essentially uh, an ID or identifier for a single article. So this will give us the list of all the articles or the content. Now we create the TF-ID of matrix, right? So how do we do that? So once we have defined our vectorizer, so we can do fit transform on that. And what things will be including in our text? So in our text, will be including title plus text, right? So we have both title. So we have both title and we have text, right? So we'll merge these two, and that will be our final text. And this is what we'll be passing in the fit transform method. Okay. So you might ask that we did not do lemmatization or any such pre-processing. We're just only removing the stop words, right? So that's the case. But of course, you can do these processing on your own. So you can remove the punctuations. You can do a lot of things before you finally fit transform your vectorizer on these texts. Okay. So our text will be a combination of both title and the text. Okay. And then how we can get all our words in our vectorizer. So there is a method again which is called the dot get feature names, and this will give us all the features uh, in our trained vectorizer object. Okay. So this is our TF-IDF matrix, which is of size 3047 rows and 5000 columns, right? Remember we had limited this to 5000 only, so we'll be considering only 5000 features. Okay. So this is the set of stop words. So as you can see, so we will have some Spanish, as you can see, we'll not Spanish, Portuguese stop words, so like entre, depoy, mesmo, things like those, right? So because we have also considered the stop words from the Portuguese language, right? So we also have TF IDF feature names, right? So we have 5,000 of them. So as you can see, so it's a mix of both English and Portuguese, like adicionar, admin, right? All those things. So so now we have the trained vectorizer object. So we essentially have the TF IDF matrix, which is nothing but a sparse matrix. So what we'll do to model a user profile? So to model a user profile, we take all the item profiles that the user has interacted and average them. This average is weighted by the interaction strength. In other words, the articles the user has interacted the most. Okay. So here I have a bunch of functions. So I'll go through them and these things will become clear. So firstly, I want to get the item profile. Okay. So so how do we create the item profile? So of course this will take an argument as item ID, which is your content ID. Okay, then you find the index of this item ID from this list item ID. So remember from earlier we had created this list. Let me just show you. So so this is the item IDs list. So it's essentially it's the list of all the articles. So let's go back to our function. So here we pass the item ID to obtain the index of this item ID in this list of uh, content or articles, right? Which is what we're calling as item IDs. Now we can use our TF IDF matrix and then just provide this to get that particular item profile, right? So it will return uh, that particular row for that particular item, right? Okay, so now moving ahead. So now we have gotten the item profile for one single item ID or single content. Now let's see how we can create item profiles. Okay, so this will now we want to create the item profiles for all the items, right? So here what we are doing. So I'm creating a variable which I'm calling as item profiles list, and here so for all the elements in this IDs, which will essentially be your item IDs, right? So we are calling this function which is get item profile. This is nothing but the same function, and this will return uh, that particular observation or row for that particular content or item ID, right? So this is what this function is doing, right? And now what we can do, we can use something called vstack. If you're not familiar, you can look about this, but we can stack this vertically, and so so item profiles will be a stacked version of all the elements in our item profiles list, right? So we are running a list comprehension here, where for each element we are calling this function which creates the or gets the item profile of that means the profile corresponding to a single item, right? And profile is nothing but that particular observation from our TF IDF matrix corresponding to that item ID. All right. So so this is how we can create the profiles for all the items, right? So this is the function for that. Now let's see how do we build a user profile, right? So in this function we have two arguments. One is person ID and another is interactions index DF, right? So you remember this data frame which we have from earlier. So there's a data frame which we'll want to create. This will be interactions person DF, as in, so this will only consider those rows which belong to this particular person, right? So that's why interactions index DF dot log person ID, right? So we only want to consider that particular person's interactions. Now we have the user item profiles. So we'll call this get item profile. So this person could have interacted with a lot of different content in history. So what we'll do, so in this particular function, which takes the input as all the IDs or all the content. So here we'll be passing interactions person df and this content id, right? So a single person could have interacted with multiple contents. So everything will be passed here in here and in this particular function, right? Get item profiles. So I'll reiterate. So this is the set of all the content which has been interacted by that particular person, and we pass this all such content in the get item profiles, right? Which will generate the item profiles, right? So this essentially gives us the item profiles for a single user. Okay. So now what we want to do, we can create the user item strength. So this will come from interaction person df, which we have created here, right? So this contains the information about all the interactions for a single person, right? So this is, remember, we're still focusing on a single person. That's why this person ID is there. And then later on in this last function, which will take this function to create the profiles of all users. Okay, so this is a quite sequential approach, and I hope this makes sense. So here in the user item strength, we can create the array of event strength for that particular for all the content which this person has interacted with. Okay, now what we can do, so we can you remember here we had said that what we'll do, the average is weighted by the interaction strength. Okay, so here we'll create the weighted average of user item strengths. So what we'll do, so essentially we're taking the weighted average. So here I'm doing np dot sum, so user item profiles, and we'll multiplying by user item strengths. Okay, so user item profiles and then user item strengths, and then divided by the user item strengths, right? So this will give us the weighted average. Okay, so because every item will have a different strength, right? So we had learned about this earlier. So as compared to a like or let's say if you're bookmarking an article, so that will have more weightage, or if you're dropping a comment in the article, so that will represent more interaction as compared to a simple view or simple like, right? Then we can create a normalized user profile by calling this function normalize, and then we'll pass this in this here, right? So we have the normalized users profile here, and this is what we'll returning. So for a single person, we are now returning this particular uh, variable, which is user profile norm, which is the normalized user profile. All right. Now we can create the so profiles for all the users, right? So what we can do, so for each person in our interactions index df, we can call this function build users profile, which is nothing but this particular function. So here we'll pass this person id and the interactions index df, and and so we'll create a list user in fact a dictionary. So here user profile is a dictionary where the key is the person ID and the user profile is the corresponding value, right? So we'll be returning this dictionary. So this dictionary is essentially uh, the profile for all the users, right? So remember, it's a very sequential approach. We first create the profile for a single item, then we create the profile for all the items, right? Then we create the profile for a single user, and then we create the profile for all such users, right? So it's quite a sequential step, right? And then we can create users profile by calling this function, which is build user profile, because all these functions, all the three functions are being called in. So this function is called here, this function is being called here, right? And this function is being called here. So finally we'll have the users profile, but just by calling this particular function, right? And it does not take any argument because now we are modeling all the users here, so it does not take any argument, right? So As you can see, so the total number of users profile we have is 1140. Okay, so this is how the user profile looks like. So this is the person ID, and this is the array. Okay, so that represents the user profile for that particular person, right? So essentially, we're trying to encode information for a single user based on whatever content they have interacted in the past. So whatever content they have interacted in the past, so we have the corresponding row in our TF-ID of matrix, and this is what we are taking. Okay, so so once you go through this code, I think this is not available in your dashboard till now. So it will be added shortly. So once, yeah, just go through this code, and this will, so this should not be a problem for you to understand. Okay. So now let's look at a particular user profile. So you remember it is a unit vector of 5,000 length, because we had restricted the number of features to 5,000. So the value in each position represents how relevant is a token for the selected user, right? So if I show you the user profile for a single, let's say this particular person ID, right? So and if I create the data frame out of this, so it looks like this. So you have the token and you have the relevance, right? So for this particular user, learning has the highest relevance, which is zero point 0.3, then machine learning point two, then machine, Google, data, AI, algorithm, graph, like, right? So I just want to know from you people. So you for this particular user, these are the tokens which come out to be the most relevant ones. So what sort of articles would you suggest this particular person? So just want to know from you, right? So you can see that these are the tokens which are the most relevant ones. So I want to know from you, which articles do you think this particular guy is interested in, or what kind of articles, right? So data science or AI, machine learning, deep learning, like things like those, right? So this guy is interested in these sort of articles, right, which are mostly around deep learning, machine learning, etc., stuff like those, right? So as you already pointed out, so looking at this user's profile, it appears that the top relevant tokens, they really represent professional interest in machine learning, deep learning, artificial intelligence, and also Google Cloud platform, right? So so we could have printed a lot more, but we had restricted ourselves to only these, right? 20. Okay. So this is how it looks like, right? So essentially for a single user, what you have, so a single user profile is nothing but a vector of 5,000 length. Okay, so what are these 5,000 items? So essentially all these features which are coming from our trained TF-IDF vectorizer. Okay. So here we are only trying to model the interactions for those users which have had at least 5 interactions. Uh, so for new users, their preference can be taken into account, right? So their interest. Uh, so I'll get to that point, Monica, which you're trying to ask. Okay. So firstly, let's see how our content based recommender looks like. Okay, so you remember that earlier we had written a similar class for collaborating filtering recommender. Now we want to create a class for content based recommender. Okay, so so here we have two attributes, which is item IDs and the items DF. Okay, so and then the model name, of course. Now we want to get similar items to user profile. Okay, so cosines, so this takes person ID as the argument. Okay, so we calculate the cosine similarity between user profile and all item profiles. Okay, So we have the TF-IDF matrix and we have the user profiles, right? So this is again another vector, and then we can calculate the cosine similarity between these two, and this will give me the cosine similarities. Okay, so now we can get the top similar items by simply flattening this list and then sorting it. Okay, so in the descending order, as in we'll have those items for that particular user on the top which had the most, which are the most similar to that particular user. Okay, so this is the concept of cosine similarity. So so essentially, for a single user, we are seeing that which are the most closest item profiles, and those will which will be keeping, right? So here we also have another argument which is top n, which I have provided here, right? So similar items can then be extracted in this way, right? So right, so in this way we are creating the similar items, right? So here we're calling the sorted function on this list, where we have the so it's a list of tuples essentially, right? So we have item IDs and the cosine similarities for that particular item, right? So this is what we are still doing at the person level, right? At the user level. So we'll return all the similar items for a given user using this particular function. Now the next part is we want to recommend items for this particular user, and of course we'll have similar terms such as items to ignore, which you have already encountered earlier. So firstly we'll get the similar items, so by calling this particular function, get similar items to user profile here, and then we'll be ignoring all the items that user has already interacted with, right? So there is a important filter function which you can use to discard those so these items essentially from the set of similar items, right? So we don't want any such item which the user has already interacted with. Okay, so now our so this is our similar items filtered, and then we can create our recommendations df on this data frame, and the what are the columns? So columns are the content ID and the recommended strength. Okay, so this is what we're calling the columns as, and yeah, so essentially, so it's a list of list of tuples. So for the first one is item IDs, which is nothing but the content ID, and the recommended strength is essentially a cosine similarity of that particular item with the particular user. Okay, so this is our recommendations DF. So now we have made the recommendations on the basis of which items look the most similar to a given user. Okay, so so now, yeah, so this is our final recommendations DF. So we'll merge this with the items DF, and so so remember, in our items DF you have the recommended strength, the content ID, the title, the URL, and the lang. So this is your article CSV. All right, so this is our content based recommender model. Now let's get to the evaluation part. So it's the essentially entirely the same thing, right? So we'll be following the same procedure. So for every single item in our test set, okay, so so for every single item in test set, what we'll do, we'll sample 100 non-interacted items, and then we'll create a list of items which will be a total of 101 items, right? And then we use our recommended system to give us the top or essentially rank all those recommendations, right? So any item which has the highest recommendation will be of first rank, and then second rank, something like that, right? So this particular evaluation is entirely the same, right? Nothing is different here, so that's why, yeah, this particular code is looks fine, because it's sort of quite it works quite well for both your collaborative filtering and content based filtering, right? So because the evaluation will essentially be the same, right? So how we are evaluating, so for every single item in our test set which the user has for every single item in the test set which the user has already interacted with, will sample 100 non interacted items, and then we'll create a list of 101 items. We'll uh, find the recommended strength for all those items, as in will find the recommended strength for all those items. We'll sort them from first rank to the last, and we'll see if that particular item which the user has already is interacted in the test set, if that comes out to be in the top 10 or in the top 5 recommendations, so that will be counted as one hit. Okay, so this is essentially the same which you have already learned from the previous class, so I'll not go through this again, right? And then now we'll just have a look at the model performance. Okay, so everything is entirely the same. So when I share the notebook with you guys, so you'll be able to make a lot of sense for this. Okay, so you can experiment around with so let's say if you're not able to understand what does this particular uh, contain, so what does this user profiles contain, right? So this is essentially a dictionary, so you can print these out and see what's happening. But I think you get the overall idea, right? So for a single person, we're finding the most similar items, and then on the basis of that, we are coming up with the recommended items, and the evaluation part is more or less the same, right? So let's just have a look at the results. So in our case, so for the content based filtering, so if you can see, so the recall at the rate 10 is around 13%, recall at the rate 5 is around 8.3%. Okay, and if you look at the global metrics, so recall at the rate is 41.4%, and recall at the rate 10 is 52.4%, right? So you remember from your earlier class, earlier lecture, that these global metrics were slightly relatively lower, right? So it seems that content based filtering works better on this particular data set as opposed to the collaborating filtering approach. But overall, uh, in general, what we want to do, so we would want to take a hybrid approach, take both content based filtering and collaborating filtering together, and come up with a hybrid set of recommendations, right? So we can do those things. So so this is how the overall performance of the model on this particular data set, right? So I hope these things are clear. So the evaluation part is more or less the same. Okay, and you remember, so in our class we had written yeah, so we're finding the similar items to each user, and then on the basis of that we are recommending the items for our user, right? So okay, so yeah, we might prefer hybrid models in real world problems. So it might happen that by using a hybrid approach, we can come up with better set of recommendations, right? So this is it, we have taken two different separate approaches for solving the same problem. We can solve the same problem by using a mix of the two approaches, right? So that can be done, but we'll not discuss the hybrid approach. So I'm getting. So Somajit is asking, so it builds models on past preferences, but for start, how we can get users preference at first? So can we not say it also has cold start problem? So it's not the same cold start problem. So the thing is, see, for a very new user who does not have any history as such, right? So of course you'll be making certain recommendations, but the thing is, even if that guy has interacted with at least, let's say, one content. So for example, let's say he interacted with an article on machine learning, right? So if you explore what is the title and the content of that article, so you will be able to create a profile for that user, right? So in that sense, it does not have that exactly cold start problem, right? So even, let's say, if he has interacted with one or two content, it will be very easy to map their interest, and the more they interact on the platform, so it will become will have a lot of information about that particular user to model. So in the case of content based filtering, we are not looking at user to user similarity or anything as such, right? So we are only focusing on the items which a particular user has consumed in the past, right? So even if they are a relatively new user, of course, if they come for the first time and if you want to show some recommendations, you'll be showing them some random recommendations, or maybe you'll ask them to suggest their interest, right? So and then based on, let's say, some keywords such as you do in your in Medium, right? So you select your interest, and then it suggests you these articles which you can go through, right? So once you have gone through a particular article, so now your user profile is has been created. So based on the description of that article and whatever the content that there is, so you can create a persona of that particular user, and then you can base recommendations along the similar lines. So that we can do, right? So so in the case of collaborative filtering, we're using the item user similarity and the user similarity, right? So we have the user item matrix, and then on the basis of which so essentially the assumption in collaborative filtering was that if if the opinion of person A is similar to person B on a set of items, so it is likely that a person A will go with the opinion of B on any given new item, right? So we're taking the user similarity in place, right, in consideration. But then in the case of content based filtering, we have not looked at user similarity, right? So here, what we are doing, uh, for a single user, we are just looking at whatever the content they have consumed in past, and on the basis of that, we are creating a profile. Okay. So I'll add, so I think, yeah, this is it. So I'll be adding the materials in your dashboard, so you can access them in just a short while. And if you have any questions, yeah, you can just ask them. And so you have an AMA at 2 p.m. and then you'll be having a data science case study after that, and then most probably we'll have time series analysis lecture. So the second lecture tomorrow. Okay, so that we can have, right? So Isha is asking, is it a good idea if in collaborative filtering we give them a mix of all type of contents and ask them to like it or any kind of interaction to avoid cold start? So of course, you can have another set of controls uh, uh, to account for your lack of information, right? So you can have other things in place. You can directly ask users that, yeah, tell me what kind of things you like, right? So so let's say if they think, if they mention that, yeah, I'm interested in this particular topic, which is, let's say, sports, right? So there will be a lot of other users who already have subscribed to sports, and their feeds are constantly bombarded by some sports articles. So this particular user can be shown those similar articles, right? So we can have a lot of controls at our hand to account for lack of information, as in the cold start problem. And I think that's why usually people go with the hybrid approach, which is a mix of both collaborative and content based filtering, right? So in your next week, one of the teams, you will be doing a project on recommender system. So that will be your content based filtering only, right? So you'll get to work on NLP a bit, and then you'll also be able to come up with very good recommender system using content based filtering, right? So yeah. So as I was saying, so tomorrow we'll be having a lecture on the second part of time series analysis, which Atul will be taking. And so yeah, so if you have any questions, yeah, just you can put them in the discussion forum, and we'll take it from there. Okay. So thanks for joining in